should we have standards in the first place? Why do we need standards? We looked at the squares, we looked at importance of keeping our planet sustainable, clean, ambient, close to the natural conditions. Then we sort of looked at some of the parameters, how we are polluting it, how we are adding different things. And then now I wanted to think about why would we need standards for, and please stop looking at your phone. So difficult for me to talk next. Okay. So why do we need standards for the parameters that we Absolutely. So guidance, and then also for mitigation to keep the means and the activity check. Absolutely. Yes. There are all the right reasons, right? We looked at all the spares, and we should know that in any case we need to limit pollution. Backbenchers, please put your phones in your bags before I come and snatch it. Okay, so we do know that we should not pollute the environment, right? If we pollute it, there's going to be impact on human health, impact on the environment, and impact on livelihood. Mostly those are the factors. But you've also realized that knowing things is not enough. We are not yet at the place where we should be ethical, so that the idea of regulation to know that everybody knows that it's not good for the environment, but to have a uniform standard that everyone can comply with it, but with the ultimate objective that we have to prevent. I put some examples here for you. So, for example, with the smart season, look at the particulate matter, right? We looked at the particulate matter, their sizes, and we said how they release from the air, and why we should limit their number. What do they do? I think for most of the times we make standards and sort of abide by them because eventually they harm us. We would not be worried about what the smoke is going to do, anything else in the air, but eventually back. So for all the 7 reasons, I think even that is right. Even if it's just for our own good, we should be putting standards out there. So just that graph showing how the finest particle, which is below 2.5 micrometer, can enter your lungs and go as far as your and impact. So once you know it, of course, you make noise about it. Right? Now people are more bothered about smoke because they know that it's reducing their heart. Bothered about smoke because they know that even if they are getting it public, they're actually smoking XYZ number of cigarettes by simply breathing the air. And depending on how much the exposure is, the number of boxes. So that awareness, I think, also helps us monitoring standards and regulation of standards. But like I said, it's not just our health, it's health of everybody else around us as well. And I don't know if you happen to look at this article which made quite a lot of noise last year, which is for Delhi, and they said that even the animals in Delhi were choppy. So there's this article, and I put the link in the post as well. So they were saying that even the animals, that's how bad I don't think Delhi is too different. Always number one, always widely. And then you see a lot of these images. It bothers me a lot. I don't know if you guys are as bothered about these images as I do. But then also we need standards because we need to know how much is too much, and how much can we discard dispose let it be a part of the business. So if we are putting pesticides on plants, then the residues that remain or any water that's passing by to be taken with it. As a farmer, I need to know how much is enough. That's going to impact my children or people who are going to eat that food or drink the water down the stream. I think that sort of question is important. But it goes back to, and I want to connect it with some of the other lectures that we've taken. You looked at the impact of your encounter with chemicals and chemical agents. So if you look at this particular image, which you've already, I'm sure, memorized for your course, the impacts can vary. First of all, the content. So the small impacts, and that's why you asked to wear those masks, which filter very fine particles. It should not be mask, right? That's the one thing that we knew. So inhalation was the major cause. There are a lot of skin irritation that is caused. You small your skin content is the major cause. But the impacts vary. Have you so for example, recently there's been a lot of research and discussion about why mixing one vaccine with the other is showing a better efficacy compared to just one vaccine. That's sort of like the reactions can be different. So they can be both good and bad. So in terms of drug discovery, they're very often used as drugs. For example, aspirin used with another medicine also stops pain or relieves the pain, etc. So those kind of impacts where 1 + 1 = 2 is additive. That can be good where for your health, for example, these two chemicals combine and stop the pain, or it could be bad where in the environment, carbon dioxide or presence of carbon dioxide, it combines, forms, any more oxidation, maybe a more part of GMG. So the reaction would lead to a more additive effect. But there's one more impact that I think is more dangerous than only additive effect, and that's synergistic effect. Sometimes, so for example, in the past 4 or 5 years, I've also heard how people were suffering from dengue. If COVID attacks them because their immunity is compromised, it's also impacting their health worse. So I think that's synergistic effect in a sense that COVID is going to impact you, your immunity, your health. Dengue is going to impact you, but now because you have one disease or one bug causing something, and then another, and then a lot of blood clots and additive effects have been observed, but they're very, very bad for the health. So I think I would categorize them in synergistic impacts. But I just wanted to give you an example as well. So from one random research paper online, I used this experiment where they said that, so this is for ozone, but if you're exposed to ozone, like 1,500 parts per billion, and just look at the scale, it's like the 1,500 part of that simple cube, let's say. That's how tiny the amount needs to be for you to be impacted by it. But let's say you're exposed for 1 hour to that much ozone, and if there is, I think it was with a cigarette. So if you're a smoker, and if you also are exposed to ozone, then your lungs will be compromised. And imagine that if around that time there's COVID or something else that is attached as well, that would probably mean instant death, in times of emergency. So I think those are the things that I want you to think about when you're thinking about chemical. It is not just sulfur dioxide, carbon dioxide, but also the number of chemicals that we're now sending into our water bodies, into our soil, into the air, and what they're capable of doing. So for some of those, we don't even know what they're capable of. And so, these impacts are important. But it's not always bad, right? So for example, sometimes you do have antivenom that is used for, if you have a snake bite or something, you do have the same venom being used as antivenom. There are examples of that, and I put those in your notes as well. Yes,
that's what they this is like, even though person's immunity is compromised, the effects that those diseases are supposed to have is adding up. Right? Instead of multiplying. I wouldn't call it multiplying, but like amplifying.
Yeah. And again, like that's I don't know. Is my sound is weird to us? Yeah. So I think that's the question that we need to answer. The impact can be, I think, both additive and synergistic. And the reason why I'm saying it is, and again, it depends. So now you've brought a very important point up. Let's say this particular experiment was found on guinea pigs. And like I said before, oftentimes the medicine or medicinal experiments that women have to take are not performed on women. Like if we keep the ethical issues with animal testing aside for now, we don't even know how one drug is going to impact my body compared to yours, because of what my immunity is and what my body already contains and its defense mechanism and any other drug that I've taken in. So far in the past, and it's not research based, so I don't think I can really say it with a lot of confidence, but I think it's varied. Varied in a sense that you have one virus coming in and making you compromise on your immunity because you want to be healthy, you want to fight the diseases regardless of what they are, what their nature is. For dengue, like people are, we know that they're bedridden, they can't even stand up. The case is almost the same for COVID. Despite not having the data, it's very obvious that some people unfortunately have had to face death, and I think it's because of their individual body and what was happening in their body as well, but also at times, sometimes additive, because you now have two bugs attacking you and making you compromise your immunity. But what does that bug eventually do? It's either damaging your lungs, so it's the impact that it's going to create. And I think with dengue and COVID together, there's been a lot of discussions, and again, it's not science or data backed, but they say that there's a lot of clotting in the brain. And if your brain is damaged, then technically your entire body is damaged, because if there's no communication, then it's useless. So I would say both, but then again, what I'm saying is not backed by any research. It's just what I've read and what I've heard and what I've spoken, all the people that I've spoken with, whose loved ones were impacted by it, where it's like instant death. So if we had time, I think if the impact was additive, and again, sometimes the synergistic may not be that dangerous. The additive might be very, very, very dangerous, depending on what the chemicals are. But again, I just want you to think about how, the discussion doesn't end at these are the 10 pollutants that we're going to be talking about, but what those 10 pollutants are capable of in the environment, how those 10 pollutants would react with 50 other pollutants in the environment, and what they're capable of. So, and I'll keep going back to photochemical smog, because that's where you see that even a natural volatile organic compound is capable of causing smog and then eventually damaging the health. So not saying that it's always anthropogenic, but mostly it's us and so I just wanted to highlight this because last time I only mentioned these and their definitions in the notes and not really discussed it in great detail, just so you understand why should we have standards. For example, now the standards shouldn't just consider the fact that this drug is dangerous or does something, but also consider if this drug combines with this. So in an air, so that's why you will see in the standards, like standards for ambient air. So they do not consider anything else in the environment when they put those standards. Those standards are for that particular chemical to be released in an environment that doesn't have anything else. Otherwise, they'll also have to take these things. So it only gets complicated. And then I wanted to give this example as well. I'm sure a lot of bio students have read this already. So I'm sure a lot of bio students have read this already. Environmental agents can also cause a change, not just in your genes, but also in your appearance. So you must have seen how, for example, in this particular part, the genes can have the ability to switch on and switch off, and I will go into it. Let's just say that our natural mechanism will have chromosomes, like genes, and those genes have characteristics, which we see, which which is why we're all so different. There are natural mechanisms for it to switch on and switch off, which is also something that I think happens with drought plants. They know exactly when to become alive and exactly when to die. So there's that communication mechanism that's not really epigenetic. But sometimes, for example, if the maternal diet is poor, the baby doesn't appear as it's supposed to be. So the environment changes, and that environment is giving a signal to a life form to change its characteristics, to change its particularly, and it's called plasticity, the ecological plasticity. So, for example, you have seen some insects camouflage. So they're green when the environment is green, and then they become yellow when it's not. We looked at locust. Locust is green when it's alone, but when it comes as an army, the attack that we had last year, they change their color. So there's some form of communication that's happening, that's at the genetic level. Again, like I'm not talking about it right now from a negative level, but if there are chemicals, and I don't know which group was doing a particular drug, where people found like their limbs weren't forming for kids because the drug wasn't properly tested in the FCG. I think thalidomide, right? So for thalidomide, you saw that not because of the improper testing, how that impacted the body. So if it was tested properly, if there was a standard, if the mothers had been told that XYZ amount of exposure will cause reproductive issues, they would not be. That's why a standard is important. That's why research is important. That's why testing it onto a natural body is important. And then because we're talking about it, and this is just an example, again, I'm bringing a lot of stuff back from your older lectures so that they make sense to you on why we put them there, what we think about it. Presence of pollution, changes in temperature, it can impact different species, right? So for an amphibian, that could mean a lot. And maybe for a mammal, like for human beings, that may not mean that much. So just the fact, and then for corals, which are the forests under the ocean, just look at how the impact varies. So even though we have standards, those standards and the impact could be like presence of one chemical, presence of one pollutant, changes in temperature, they could be drastic changes in the environment. Well, which is why we need to be given more clarity on what the standard should be and how much should be limited. But because I was talking about it, it sort of made sense to put the discussion about toxicity and ecotoxicity in here, because so when you eat a medicine, let's say if you're eating Panadol or any other painkiller, it's numbing your cells, right? It's allowing your cells to be. So basically what happens is when you're taking a drug, you look at how many bugs is involved. Bacteria, antibacterial properties are just. Okay, is this better? Okay. So if it's bacteria, you look at how many bacteria is it going to kill. So for example, if I'm testing a drug, then I look at the lethal effect. If I'm eating medicine, I look at the lethal effect, and then I would want it to be, I would want the lethal dose to be as minimal as possible. So let's take a tiny medicine, and then it kills the viruses or kills the bacteria by entering your bloodstream. So that's the lethal dose. But then for environment, I think this toxic impact, they're more or less the same things. But here the purpose is, a different chemical, and the purpose is to kill a particular life form. Here we could think of it with respect to the environment and or even a human body and how it would have toxic impacts on that life form. So here, like the toxic dose is high. So if you think of it, if I'm taking a medicine, the lethal dose should be really, really low. So let's say the LD50 means 50% of the population is gone. Okay. And then of course there 100% of the population of let's say virus is gone. Whereas for toxicity, so you would want this to be as low as possible, but you would also want the toxic impact to be as low as possible as well. but sometimes they do not translate. So if you're using a medicine that is really powerful and is killing something in your body, it also has a lot of toxic impacts in your body. Let's say this is the concept, like, so this again is therapeutics, which has to do with medicinal process of chemical. But let's say that we are looking at, the same chemical, and it's basically telling us that it's toxic. So toxic to that particular virus is okay, but toxicity to a human being, to a life form underwater is not okay. But how do you make those like how do you? It means that every time you're testing a drug, you not only have to test it for human beings, but you also have to test it for every other life, which we're never going to do. Which is why, at least in the case of human, we have to be really, really cognizant, and you might have seen how drug testing and FDA approvals take forever. Because when we were looking at this ecotoxicity as an entire course, we were looking at how chemicals were approved after 1, 2, 3, 4, 5 years of testing, and then 10, 15 years later, it was found out that it was not good for the health of the birds, and the entire bird species were extincted. Particularly, for example, in the case of insecticide and pesticide, we have seen entire populations of birds wipe up, and then that impacts the environment. So, not necessarily going into the details because this is a whole new area in itself, but I thought I should introduce this to you on why do we need to worry about these chemicals specifically in the case of the environment. We have been talking about electromagnetic radiations, just gave you a mix, so I'm sure that it's very, very fresh in your head. So there is that spectrum that is coming from the atmosphere, is filtered. We're mostly just bothered about the visible light. But around us, there are a lot of equipment that release the same radiations that the atmosphere has blanketed us from. So yes, these radiations naturally exist. Yes, there's a natural mechanism of blanket for the atmosphere to filter it. But there are a lot of devices in our around us that can release those rays, which we know are not good for health. Long-term or short-term exposure, it depends. For example, people will tell you, bar X-ray na karaye, aapke acha nahi hai. Because it's an ionizing radiation, it can damage the cells in the body. But also, then again, you can think about it, some of the radiotherapy for cancer-causing cells is done through those. So if you want to burn, kill the cells, that's exactly what you do. So you just have to think in terms of applications and what you want to achieve. But in general, for a healthy human being, you would want to avoid those radiations. And that brings me to a question that was really popular last year, which is, is your cell phone capable of killing birds or harming birds? And have you ever read anything about it? It's okay if you. Yes, sir. ठीक है. बिल्कुल. Anybody else? Like you must have heard something about it. Yeah, absolutely. Exactly. So that's like one area in navigations that because there are now a lot of navigations that mess up their communication. But you will now see a lot of research in this area. More than the mobile phones. And the mobile phones are not good for us. As you said, we've been reading about it for the past 5-8 years, because before that, people did bother. अपने पास रखने की से जो radiation से करती है, long-term exposure that is not good for you. We know that sort of. But more than the mobile phone, because the radiations weaken, it's actually the towers that impact birds more. Because after they come, we have a relatively, we have a skull, we have bodies that have adapted. Some birds are really sensitive, or उनके brain या उनका जो भी cognitive mechanism है, or their cells are not as protected, not as, and of course they don't have the mechanism to protect themselves after that either. So that research actually has shown, and I was even yesterday I was reading researches that are conducted in Pakistan, where they've shown how long-term exposure to radio waves is impacting life forms. So yes, not directly, but although the cell phones have very little contribution to it, actually the towers have contributed to different damages and within the cell. So back to the question on why, like I said, sometimes and you can look at it in different ways. The radiations are not good for us. We need to protect ourselves from them, unless, God forbid, we're suffering from things like cancer, where we have to limit the cell growth, or we have to burn the cells and get rid of them. That's when you can make use of them. Similarly, a lot of chemicals are not good for us, not good for the environment, but oftentimes we use the same. And I do remember some of you in the chemicals around us post, you had posted about the medicines you take, and then you had posted how one component, even a single component of that medicine, long-term exposure of that component is not good for you. So yeah, for all the selfish reasons, it's we should take care of it because we should be taking care of our environment, but mostly we're concerned about it because we're concerned about the human being. Just a quick recap. In 1972, we had the Stockholm Conference. Pakistan established its Ministry of Environment in 1975. In 1983, we formed the Pakistan Environmental Protection Council. After that, in 1992, we have, and I love this book, the National Conservation Strategy. It was Pakistan-wide, it was very heavily researched. And then in 1993, we came to the National Environmental Quality Standards. I'm going to be criticizing it a lot later, but for now, we'll just look at how they thought, okay, now we have the standards, but we need to make sure that there are certified labs. And then we also needed to make sure that universities have self-monitoring and reporting tools, because industries are opening everywhere and it wouldn't be possible for EPAs to go and monitor everything. So, but now, for the first time, I'm going to be asking you to take out your phones and maybe look at the Pakistan Environmental Protection Act, which is the first environmental act of Pakistan. It should be an old gazetted document. Just look it up, and while some of you are looking it up, maybe you can also tell me if you've heard about climate policy in Pakistan, water policy in Pakistan, or air policy. Have you heard? Why do you open Pakistan? Absolutely. And then that's exactly how it should be, because provinces have different industries and different populations. Unfortunately, for us, the same national policy is just called, Punjab climate policy. There's not a lot of change in the content or in the standards, but technically that's how it should be. But you should have like the national standards, which also more contextual. Prevention standards, as far as I've been aware, we just use the same standards. Yeah, we just lower it. Like on page not only that's the sign. Okay, so Pakistan Environmental Protection Act, and do you want me to open it here as well? Because I know otherwise you'll never look at it. Okay, so I think you can just look at what the act says, maybe just the definition. Yes, Anna.
I just have something to add here. I was looking at 1997 act and the new 15 act. It has the exact same objectives.
Yeah, exactly. So why do you think I remember, as long as I remember, it's literally just the same.
Exactly.
Yeah. So if we're not updating it, look at how much our environment is evolved. And in documentation, if that's where we still are. We just update maybe some of the terms. So basically, like for example, in the case of water, I can tell you that there are only 32 parameters, for example, for effluents that we have in wastewater. In those 1 or 2 chemicals that you guys looked at, there were at least 10 or 12 chemicals, right? They have been added into our environment for the past almost 10, 20 years as an environment is evolving. For the past 20 years, our standards has been more or less the same, and we haven't really achieved anything. So while it's, that's why we talked about the why too much. It is really important to us. It is really important for us to know how we achieve that environment. But if in a country like Pakistan, where the population is too high, we are using all sorts of things. We are even using the banned stuff that is banned everywhere else in the world. But we only have these 30, 40 standards that the industries have to report. And I mean, I don't know. It doesn't satisfy me, the little science that I know. But we just need to know how inefficient everything has been if we want to improve it. Yes, Dan.
The same comparison about soon after 18th of next year, we बाकी provinces को पंजाब के standards को
Actually, वो सारे national standards जो थे ना, just like I said, the Pakistan climate policy was formed in 2012, 2018-ish. And then we said that अब हमने इसको provinces को दे दिया. It just means climate policy Pakistan से वो अब climate policy Punjab हो गया. Content से वैसे. Similarly, the standards that we have are national environmental policy standards, which have now become Punjab's environmental policy standards. Technically, we should have a scientific rigor to be able to update, add more stuff, and maybe for city to city have different standards. We do not. And that's the problem. That's why I think, and I was asked this question last year of why am I teaching, this, which is not really science about some people. If you know all the science, if I tell you about all the pollutants, all the chemicals, but we're not aware of what the regulations around us are, I mean, how can we stand up and say, some scientific community needs to be formed, needs to stand up, update this. So for our future generations to want action and to want change, it's important that you know what's already there. And I can tell you that there's not enough. We don't have enough manpower, we don't have enough resources, our EPAs are limited in their efficiency. In the resources that they do not have the capability to go and test, we do not have that many labs. In fact, like recently you had a fire incident in the world. Why did that happen? Because you had a random person running something in a residential area which wasn't supposed to be doing. How could we have stopped it using these regulations? But maybe even their neighbors didn't know what was happening. Right? So a lot of these things, again, the EIA of why it shouldn't be there, the standards of what they shouldn't be emitting in a municipal site. Because if they're polluting, they're supposed to be paying a penalty. If they are taking something out, then they're supposed to be treating it before dumping it into the environment. But how do we regulate it? Like if I were the head of EP and you come to me and tell me that the water is not good now, just look at how inefficient the entire process has been since its inception. I think we've just done things because we're asked to do it. So we've been a signatory to Paris Agreement because of course we like to be presented as good people. But other than this banyan tree tsunami, I don't remember any single initiative that we've taken which is praiseworthy. How good or bad it is, still okay. At least we've done something as a nation. We're committed to something. Other than that, we've never really committed to a better cause. Yeah. Yeah. And if you look at this in detail, they also say, so with respect to 1997, maybe it was okay to pay, for example, 1,000 rupees or even now, let's say 100,000 rupees. There's no strict regulation. If I'm an industry and I have to pay 100,000, who cares? I take 500,000. I bribe perhaps another 500,000. Yeah, absolutely. So good that some of you are engaging with it, have engaged with it. When I was taught all of this, I had to literally memorize everything in the Pakistan environmental laws. But I did want to have a glimpse of what it is like, what are the regulations. So for example, even for when you go back to your lectures division for your lecture on EIA, do come back to the act and see what it says about IE and EIA and what is it has included. And even there, it's so random, right? Some of the projects they are there, but some of we're adding so many more projects, and they're not. Our list of what should do EIA and what shouldn't is not diverse yet. So I think even a lot of green projects also have impacts. So even they should go through those IEs or EIAs if needed. But our regulation is not that diverse yet. Okay, so like I said, I didn't want to show it to you because some of these are very, like you know them very well. And we did talk about how our standards set. They said that an annual average exposure should be this, but we talked about acute and chronic. So if you have a lot of exposure for a short time, that's also bad. So the standards will have some of those details in there, and it's something that needs to be taken into account. I generally like to convert and you can use tools online to convert them into parts per million because they give me a better sense of scale of how minute the quantities actually are. So they're not like a truckload of something, but maybe for SO2, for example, 0.03 parts per million should be your average intake in a year. But just a sense of scale, just a sense of understanding that yes, you looked at the pollutants, yes, you looked at the environmental impacts, yes, you looked at the health impacts, but what does that mean in terms of number? And how has that number been decided? That number has been decided by all the research that took part on or the impacts. For example, if you are aware of Mina disease, which was caused due to methyl mercury in Japan, it had very obvious impact. And even though the health impact was obvious in one part of the world, it led to a regulation for the rest of the world as well. So, it doesn't mean that we have to go and expose every human being to the chemical. Sometimes we just see it from our failure stories and then do some research to make sure that some standards are put in place. So yeah, so for those pollutants that you know already, maybe you can just look at them on what the quantities are. But back to the discussion on these are more your notes rather than the lecture slides. Back to the discussion on how diverse everything around us is. How many chemicals are present around us? And is it okay? So if you looked at the ambient air standards, they had the typical classical air pollutants, right? Only so most of these in the Pakistani standards. Did you see any pointers for this? We did not. Did we see these? Some of these were there because there's a lot of emphasis on heavy metals, specifically with respect to industries. But we did not see a lot of these in the Pakistani standards. So what happens then is, so I picked it, I think, from WHO. What happens then is your national standards have not told you about it. And then the industry is told to be abiding by the WHO standards or another standard that would be the secretary. We've already made the process of and then it's not easy to go because if I go from the EPA, then I'm only allowed to be looking at those few parameters that I've given them and the few standards that I mentioned there, not necessarily. But yeah, so those are like the diverse, again, just types. We looked at what kind of impacts there could be, yes. आपका जो आपने अक्सर सुना होगा, have you ever looked at people saying we shouldn't be using a lot of tissue papers? Thanks a lot. So there are two there are two ways to look at it. आप tissue paper बहुत देर तक इस्तेमाल करते हैं. एक of course there can be biological pathogens there, which is because you're important. Right? So if someone else is around, touching it, your cleaning staff, they can get in touch with their bacteria. But दूसरा जो है आपने बहुत सारे देखे होंगे tissue paper is actually a very nice conversation. Not nice, bad conversation, but nice for the So if you've looked at some of these wipes, the tissues that are soft and they're not completely paper and more environment friendly, they have plastic. So they're blended with plastic. Which are the bags which are not entirely cloth or entirely plastic, they have a blend of plastic. Any particle that's coming out of it is microplastic. A microplastic is थोड़ी बहुत discussion हम कर चुके हैं. ठीक है. A fibers के case में, one, if you just have that tissue paper in your hand, and let's say if it's now a blend of plastic or just the particle in itself, जब dust करते हैं, there's like a lot of dust that comes off of the tissue paper. आप देखेंगे कि आप ordinary restaurant में जाएंगे, वो पूरी quality वाला तो एकदम से वो dust छोड़ देते हैं. We don't know instantly, let's say if it enters a water body, how will it impact a small like this? If we breathe it, हमें वो अपने lungs को थोड़ा सा zoom in करके दिखा कि how a smaller particle, a finer particle that is not visible to our eyes is not good for us. जब भी हम dusting करते हैं, उस dust में सिर्फ मट्टी तो नहीं, there are also a lot of these other particles. Now that brings me to the actual conversation, which is these carpets that they've been home, breeding grounds for a lot of fungi, but also जब इनकी भी हम सफाई करते हैं, there's always some particle coming out. These are natural materials, okay? They're not too dangerous. कोई cellulose waste, कुछ भी आपने घर में रखा हुआ है. Something is coming out of it, जो कि continuously आपके environment को, जिसमें आपको बाहर outer environment change हो रही है because of presence of particles. These are also impacting our environment. And as far as radon is concerned, I think that has more to do with the nuclear sites that are more जहाँ की geography थोड़ी फर्क हो. So maybe not every place. But we do not know, maybe for places like GB, we should be monitoring some of these nuclear activities because we actually have active sites. How is that happening? इसलिए है कि कोई geothermal energy source, ever sources generally क्या होते हैं? They are nuclear in nature, most of them. So वो सारी चीजें, I don't know, as an ordinary resident who's sitting in the north, I do not know what's around. But who is supposed to be telling me this? My regulatory authority, the research organizations, because I would, if I'm not told, which is why a lot of people say ignorance is a bliss, because with reference to environment, the more you know, the more confused you get. And now I also need to know what's around me, not just, now you also need to be worried about your indoor air as much as you are about your outdoor air. But they can be site specific, but I think we do have this problem. And maybe because this, and again, now there's another way to look at it. A lot of this has been developed with a focus on the developed world. And as you know, in the US, this has been, radon pollution has been an issue. And of course, it's become a life or cells with impact of that. We don't even know what, the core parts, the developing world part, how many more pollutants could be added here. And the list is exhaustive, it's an exhaustive list, we never end. You just keep adding stuff to it because we are making so many more chemicals every single day for our convenience. And they are being added to the environment. So we don't even know how exhaustive the list needs to be, but we need to be aware of what's being put in. And what are we taking in return? Again, these are your notes. I wanted to bring it back to why some of the classical pollutants that you studied, what their sources are, and what the major health impacts are. So you don't, you can just read the data. And then also before we go, we did look at these as well, right? So for smog, both. We just look at the visibility, so there are these air filters, and they tell us how clean the air is just based on the opacity. We also looked at the noise pollution and said that it shouldn't be for Pakistan NEQs, and it varies from place to place. For Pakistan, it's 85 dB. But now I want you to look at, because the table that I showed you for ambient air, you should be able to find a similar table for the gaseous emissions from the industries, as well as liquid emissions or effluents, which is both for municipal and industrial waste. We only have 5 minutes, but I think you need to help me out and go and see what's there. So just back to your forms, and you start looking at the standards for gaseous emissions and standards for industrial effluents. And then see if it's any diverse than the other standard, or is it still very limited list?